Hey guys, so today what we're going to look at is something called a geometric sequence. We sort of explored it on Monday when we were looking at arithmetic and geometric sequences when I introduced it to you. So we're going to find only specific terms in the sequence using a formula. So I want you guys to take out packet 12 and we're going to recap from Monday about what a geometric sequence is. If you don't have it, you could print it off the Google Drive and go along with us as we move along. So, just so you guys are aware, a geometric sequence, when we looked at it on Monday, is just a sequence of numbers that we get to or is generated by either multiplying or dividing by a common number. Now, specifically speaking, we call this a common ratio, but we never use division for a common ratio. We use it as a form of a fraction. So, today it's going to be really important that you know how to switch a term in a sequence from knowing that you're dividing into a fraction. So that's what we're going to be looking at today. So again, these are the terms of the sequence. This would be your first term, second term, third term, fourth term, fifth term. This number that we're multiplying by, either 1/10 or 2, is our common ratio. If it's a whole number, it increases. If it's a fraction, the sequence is going to decrease. Okay, so that's really it. So I'm just going to ask you guys, we're going to skip over the front, we're going to skip over the do now, and we're going to go to page 2 in the packet and look at the top and fill out the top of the page. So a geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a common ratio. So pause it to copy it down. The common ratio can be any integer or fraction, so you'll need your TI-84 to get the ratio in fraction form if need be. Some of you are going to be able to see it right away, but some of you will definitely need the help of the calculator. So what we're going to do is we're going to go underneath this and we're going to find the common ratio of each set of numbers. The easiest way to do this, if you don't have good multiplication skills, is to start with the last term and divide it backwards by the term before it. So let's look at the first one. Turn to page 2 and on the packet, and we're going to practice it. Oops, I did that already. Sorry. All right. So most of you can tell to get from 2 to 8 and 8 to 32 and 32 to 128 would be by multiplying by 4. But like I said before, some of you are going to have a hard time finding that number. So what we're going to do is just get practice with finding it by starting with 128 in your calculator. You're going to then divide it by 32. And when you plug that in your calculator, you should get 4. And that just means that's the number we multiplied 32 by to get to 128 is 4. So when you're dividing backwards, it shows you what operation you should be performing forward. And that should match up for each number in the sequence. If it's not the same number, then this is not considered a geometric sequence. So let's try 32 by 8. So if we divide 32 by 8, we got 4 again in our calculator. And then we're going to test it with 8 divided by 2. And again, we get 4. So since we get 4 on each one of those numbers when we're dividing backwards, we know the common ratio is 4. Therefore, we also know this is a geometric sequence because we're multiplying each previous term by a common number. Okay? So let's try the next one together, and then you're going to do one on your own. So the next sequence is -80, 20, -5, and 1.5. So this sequence is going down, so we know our answer is going to have to be a fraction of some sort. If you're not sure, many of you know you're dividing by -4, but that's not really what we're talking about here. So I want you guys to make sure that you get this down in your calculator. So we're going to start with 1.25. We're going to divide it by -5 in our calculator, and you should get -0.25. And that's what it should look like. But because we don't want it in decimal form, we're going to change it to a fraction by pressing math enter, enter, and you should get -1/4. Now we're just going to see if each subsequent term in the sequence has the same ratio just by dividing backwards again. Make sure we get -0.25. So now what we're going to do is we're going to take -5 divided by 20. You'll notice here, yes, it came out to -0.25. And then we took 20 and divided by -80. And once again, we got 0.025. Now again, when we write it as our common ratio, it's supposed to be a negative 0.4, a negative 4, negative 1/4. So make sure you change that to a negative 1/4. That is the number that we're going to need to use. We're not using the decimal, we're using the fraction form. Okay? So what I want you to do is I want you to pause the video and try this one on your own to see if you can come up with your the common ratio on your own. Hopefully you came up with a common ratio as 2. When you divided backwards, 2 should have came up. Otherwise, please go back and please try that again. If not, if you got that, then great. We're going to then move forward. Okay? So now we're going to flip the page because we're going to skip over it. This is just saying, we're going to need to use a formula. Make sure you got all the notes down. So because we're dealing with common ratios, the numbers in the sequence are going to increase or decrease extremely fast. So just recognize our answers are going to either be really tiny fractions or really big numbers. So flip it over, and now we're going to look at a new formula that's going to help us find specific terms in a geometric sequence. So on this page, it's going to say, what is the 12th term of the sequence? -3, -9, -27, -81. Well, we notice that it's jumping really fast, so that means that it's not arithmetic where we would add 6, add 6, add 6, or subtract 6, subtract 6, subtract 6. It's definitely getting bigger because the numbers are jumping faster. So we know we're multiplying by a certain number here. Now, if you didn't know we were multiplying by 3, we're going to use our divide backwards to get our common ratio. But let's just look at the formula first before we attack this problem. So here's the formula. It's a sub n equals a sub 1 times r to the n minus 1 power. So this is an exponent up here. So a sub n is the value of the term we're looking for in the sequence. A sub 1 is still our first term in the sequence. R now is the common ratio, and we're going to use that. We're going to represent it as an integer or fraction. And then the term is the n is the term we're looking for. So in this particular question, we're looking at what is the 12th term of the sequence, -3, -9, -27, -81, ... So we're going to still follow the same rules that we did yesterday. We have to find our specific information and write down the formula. So first thing is we have to find the first term, which is -3. And we want to find our common ratio. Now we're going to divide backwards, -81 by -27. You should get 3. -27 divided by -9, you should get 3. -9 divided by -3, you should get 3. So our common ratio is 3. And our n is 12 because we're looking for the 12th term. So make sure you look up here to find that term that we're looking for. Next step is fill all this information into the formula. So a sub n is a sub 12 because we're looking for the 12th term. We're going to replace a sub 1 with 3 because that's our first one. And then we put our dot for multiplication, but you guys need to start using these parentheses. You had a hard time with those yesterday. So anytime you're replacing numbers, please remember to put the parentheses around the number. And 3 is our common ratio, so that's what we're plugging in for r, to the 12 minus 1 power because 12 is the term number that we're looking for. Next step is you're going to plug this into the calculator. Now, just remember when you're trying to get this exponent in here, you need to use this caret button to bump it up into an exponent. And then once you do that, you press enter and your calculator should look like that. If it doesn't, you need to go back and re-practice it. Therefore, a sub 12, or our 12th term of the sequence, is -531,441. So that would be how we would find a specific term in a geometric sequence. Okay? So we're going to practice one more together, but make sure you pause the video to see if you wrote down the notes, and then we're going to go to example 2 at the bottom of the page. Okay, so this particular one, it looks a little different. It says find a sub 8 for the sequence 171.5, 24.5, 3.5, and 5.5. A sub 8 just means it's notation for we're looking for the 8th term of the sequence. So that's how you're supposed to interpret that. So we're still going to follow the same steps. We notice it's decreasing quickly, so that means we're going to be multiplying by a fraction of some sort. So first you're going to write down the information. We're going to find our first term, which is 171.5. And then our n we know is 8 because that's what we're looking for, the 8th term. That's our subscript there. Now the common ratio is going to be a little different. We're going to divide it backwards in our calculator. So you're going to do 0.5 divided by 3.5, and then you're going to do 3.5 divided by 24.5. And you're going to get a really long decimal. So I just want to make sure you guys remember to turn it into a fraction. So our common ratio for this question should be 1/7. So once we found all the necessary information, we're going to plug it into the formula, fill in all the values, and you should get a sub 8 equals 171.5 times 1/7 to the 8 minus 1 power. Pause it and make sure you get this down. Next, you're going to plug that whole thing into your calculator, remembering to use your caret button and your fraction button. So it should look something like that in your calculator after you've plugged it in. Please plug it in to practice. Now with this weird looking decimal, you definitely want to see if you could turn it into a fraction, which I was able to do. Therefore, the 8th term of the sequence is going to be 1/4,802. So these are how we're going to find different terms of a geometric sequence. If the term can't be turned into a decimal, into a fraction, just keep it as a decimal, okay? So if you have any problems with this, please email me. And you're going to definitely pause the video, make sure you take down all your notes for this part of the packet. And we're going to go to the Google Classroom and complete the Google form on geometric sequences. They're the same questions that are in the packet, but just in digital form. Okay? Have a good day, guys.